Hi, my name is Sergey, and today I'm going to teach you about Mongoose Library, and specifically about events. Here on my screen we have Mongoose website, we have an editor, and we have a terminal. So what is Mongoose? If I go to developers documentation, I can see that Mongoose is a networking library for C++. It implements event-driven, non-blocking API for TCP, UDP, HTTP, and so on. And we have a quick 2 minutes integration guide, right? So it says that we need to download 2 files and we can create a simple application that implements a web server. So let me do that. In my terminal, I create test directory. I go to it, there is nothing in it, and I need to download 2 files, mongoose.c and mongoose.h from the GitHub repository. That's the GitHub repository. So it's mongoose.h, and I simply copy it. In my editor, I go to test, I open mongoose.h, copy, save, and I do the same for mongoose.c, copy, and save. Yeah, there are more elegant ways to do that, but I'll do it in a simple way. And then I create a main file and copy the snippet from the integration guide. Okay, and now I need to compile it and run it. cc main.c mongoose.c, and then run a.out. So it runs, and now I can go to port 8000 and see that web server running. So here it is. And if I go to the URL API hello, I should see a JSON response. So let me go to API hello. I see that JSON response. All right. Let me simplify this thing a little bit. So we just, when we get a request, we just mg http reply with simple message. Hi, something like that. Okay, so let me explain this simple application. At the beginning, we have Event Manager. This is a structure that holds basically all connections. Then we initialize the Event Manager, and then we create one single listening connection. And then after that, we fall into infinite loop, calling function mg manager poll, and then we also specify this function fn. This is an event handler function for every accepted connection on this port 8000. We can have more than one connection. For example, we can have several listeners working simultaneously. For example, we can start one on port 8001. Okay, and when we do that, we have 2 connections running. There are 2 key structures here. One key structure is the event manager, which holds all connections, and another key structure is the connection itself. When a new connection is created, and here we're creating new connection by creating a listener, we add this connection structure to the event manager. Every time this listening connection accepts a new connection, it also creates another connection and adds that to event manager. And the behavior of every connection is specified by the event handler function. So in this case, it's specified by this fn function. And the signature is pretty simple. So the event handler gets 3 arguments. First is the connection itself that receives an event. The second argument is event. And the third argument is event data. So event data is the void argument that its meaning depends on the event, right? And what are these events? We can take a look at these events in mongoose.h, mg event. So if we search for mg event, then we see this big enumeration, which lists all the events that that exist in Mongoose, right? And probably the best way to see how it works if we just add a trace to the event handler function here if we just trace the received event. So I do mginfo, and then we say connection, and then show the connection ID, event, the event number, and event data, the event data pointer. Okay, and that's the connection ID. Every connection has a numeric ID, which is auto-incremented, the event and event data. Okay, now if we compile and run this, we're going to see something like this. So notice that we have two connections, connection 1 and connection 2, and each is getting event number 2. So we can go to mongoose.h and correlate the number to the connection name. But probably it would be better if we go and also show the connection name. So basically stringify that list. So let me do that. So we want to show the event names together with event numbers. Okay, so let me just record a macro. And here we go. All right. And then I want to repeat it for all lines. Okay. So now we have names for all the macros, and together with the event number, we also show the event name. So const char names equal, and here we have names indexed by event. All right, let me compile this. So now we have event ID and event number. So we can see that we have an open event for connection 1 and connection 2. So basically, we have two simultaneous connections, two listeners on different ports, and each of them received an open event. Open means the connection was created, right? And then after that, we have a poll event. What is a poll event? Poll event is sent every time this function poll is executed. And this function poll, it triggers either on a timeout, and the timeout is here specified to 1,000 milliseconds, or when any network event happens, right? When we have some data on any of the connections, the poll also exits. So that's why we have two open events and one poll event for each connection every second. Okay. Now we can have also a client connection here. Like for example, let's see, we have like a lot of events, like low-level events, open, poll, DNS resolve, connect, like HTTP events, WebSocket events, MQTT events, SNTP events, and so on. But obviously, since our HTTP listener is HTTP, we will never get MQTT event on this connection, and we never get SNTP event for this connection. But just for the sake of showcase, let me start one SNTP connection to connect to the network time server and get the current time. So we do mgsntp connect. So we also add it to the current manager, and the URL would be it's UDP protocol, say time google.com, and port 123. That's an NTP port. I can specify different event handler function. Usually that's the case, right? So for a different purpose, you create a different event handler function, but we can have just one, just for the sake of demonstration. So fn. So now we have a third connection, and the third one is SNTP. So let us start this again. Okay, let me stop this. And here we can see we have like three connection open. So we have created three connections. And for the third connection, we have like a bit different pattern. So we have event resolve. That means that destination address timegoogle.com was resolved by the built-in Mongoose asynchronous resolver. We got an IP address for that destination, and then we connected to this. So this event means that we connected to the timegoogle.com, and we sent also the request. And here we've got a response, SNTP time, right? And if we see at this table what is the meaning of event data, so we can see that's the pointer to the number of milliseconds since 1970. And we can probably also print it. So currently this event handler function ignores all the events. It only reacts on the HTTP event, but we can let it react on the SNTP event. If event equals mg event SNTP time, then UN64T now equals event data. And we can say that current time in milliseconds, this is the current time, and show it. Okay, let us compile, run it, and we've got a message. So this is the current time in milliseconds. So I guess this gives you an idea how events work. So now I want to show you what is the event flow for the typical web request. Let me remove all these extra connections just to make things cleaner. Okay, so now we have only one listener. So we have that listener created and it receives pull requests. And now if I refresh that browser page, I see the high response, and in the event log, connection number 2 was created. So listening connection got a new connection request in, and it accepted a new socket. It created a new connection, and that's why we see a connection number 2 was created and mg open event was sent. And then immediately after that, we see the event accept. That means that that connection was accepted. This is an inbound connection, not a client connection, not an outbound connection. And then after that, we received all the HTTP headers from HTTP request. And then after that, the whole HTTP message. And that means event HTTP message. So that means that we have buffered all HTTP requests. So at this stage, we triggered this branch of code and we created a response. So by calling mg HTTP reply, we created a high response and added that to the send buffer of the connection. And Mongoose, on the next mg-mgr poll, it drains that response to the destination server. So that's why we see here event write. So we write that response to the destination. And then here we see another connection, connection number 3. So you might wonder, what is that? And that is the browser trying to fetch a fav icon. So the icon to show on this tab. It always does it. So for every website you access, it tries to show the icon, but we have no icon here. So we see nothing. And that third connection then gets closed, and then the second connection gets closed. So I hope it helps to understand events concept. As you can see, this event handler mechanism, it's very similar to JavaScript one. So you have an object, in this case it's a connection. That object can receive many different events, and you write your code as reactions on these different events. So this concept is pretty much different from the sequential flow in BSD sockets interface. And I guess in the next video, I'll explain why BSD socket interface was created that way and why it is different from event-based mechanism. So thanks for watching this video. See you in the next one, and take care.